Dealing with the arc measure, the measure of an arc was always equal to the measure of its central angle. So in this case here, the measure of this arc equals the measure of the angle that's created by it. One of the things I want you to notice is how we write arcs. We write arcs, and cat is too far away, and we put that little arc symbol over it. We write angles, and we put that little arc inside the angle. All right? If you keep that kind of together, when we start talking about what's called arc length, you'll be able to distinguish between the two. Okay? Arc length is when you are measuring distance on a circle. It has nothing to do with the degree measurement. It's how far did you walk from A to B while you're on it. Yes, ma'am?
Okay, I know this might be like a little ways away, but on like the test,
Yeah.
I'm assuming we're gonna have to like label a circle like different like diamonds.
What do you mean?
And stuff like, are we gonna have to like label like like all the vocab and stuff,
Yeah.
like the radius and all that? We're gonna have to like label all that, right?
I don't know. I've done that in the past, like like a little what is this, what is that type thing. I've done that in the past, but I haven't written the test yet, so I have no idea. Why do you ask?
I was just gonna ask if we were like, if it was gonna be like a word bank or something, or if we actually like write out what it is.
I don't normally do stuff like that. It's very rare that way I actually have stuff like that on a test, because I'd rather set it up that if I just say, hey, what's the arc length, and that way you know what parts you have to use, if that makes sense. Same thing as we get into the circle things, what we'll have here very shortly is we're going to have to work with we can find segments, we can find angles, they have relationships between the arcs they run into, whether you're inside, you're on the circle, you're tangent with the circle, or you're outside. There's all these different rules, so if you understand the bit of the rules, there's no reason to know this means this, this means this, this means that. You're applying that into these rules, and that's kind of what I'd rather do, as opposed to.
Which one of these is a radius? Which one of these is a diameter? Very well. I'll probably this the rest of the day. Yes, I do.
All right. Anyway, so arc length. Why are you shaking your head at me? I try to make you laugh to have a little bit of fun. I know geometry's boring. I get it. At least I can keep you entertained for try to at least for 40 minutes. That's all I can do. What do we call the perimeter of a circle? Did we talk about that yesterday? You bet. The circumference. So it's a portion of the circumference. So what we're going to talk about today is called arc length. Arc length is actually in chapter 11. Okay? What's weird is that we talk all about circles in chapter 10, but then in chapter 11 we start talking about surface areas, and we start talking about all the different area formulas, and then they bring back in circumference in chapter 11. Last time I checked, it would make a lot of sense if you're talking about a circle to probably talk about circumference when you're talking about circles, as opposed to, hey, the area of a triangle is 1/2 base times height. Oh, by the way, there's this crazy thing called a circle that has a circumference. So I always bring it into this chapter. It's technically section 11.4, but I call it 10.2.5 because it's part of 10.2. So the difference here we're going to say is that we have this thing called arc length. Arc length is going to have some funky formula to it. And what happens a lot of times is that it's going to be written differently. Okay? It'll be written out differently. Whereas if we said the measure of the arc, we always had this with the M value with the AB with the arc over it, or 3 letters, depending if it was longer arc or whatever. If it's going to say arc length, it'll quite literally say, find the arc length of AB. Or it'll say length AB. It's not meaning that we're finding the segment AB. If I was going to ask you to find that segment, I'd have you do something different. And I would completely word that differently before you see what you have to worry about it. Would be nice. So, arc length. As I said, arc length is going to be portions of the circumference. Yesterday we talked briefly about what the circumference meant. Remember, the circumference was your distance around the circle. So it was the circumference is equal to 2 pi r. But we also wrote down that twice the radius is equal to what? Yeah, it's equal to the diameter. So we could also say that circumference is equal to pi times the diameter. Diameter is just chord. We don't need to worry about. We already defined that. Question that does come up from time to time is about why it is written 2 times pi times r, not 2r times pi. The math etiquette police come around, and there are rules for writing out algebraic statements and stuff. The rules are you always put numbers first, and then you put symbols, whether it's like imaginary or pi or square root 3, any of those things, prior to putting anything else in there. It's just the way that they write out terms. That's why it's 2 times pi times r. Same deal with when it's just pi times the diameter, because the diameter is the variable. We don't say diameter pi, but yet when we have our answers, if my radius here is 6, what's going to be my circumference? Well, I would take 2 times 6 times pi, and I get 12 pi. Then that's when the constant comes first before the pi symbol. Okay? It's just a math etiquette thing. It's just how things are written out. Finding circumference is ridiculously simple. It's just doubling your radius. Okay? That's all it is. Also, we're going to leave our answers in what are called, in terms of pi. What that means is that if you ever have to press a button on your calculator that says pi when you're multiplying out, it should keep pi in your answer. So if you have the multi-view calculator, if you type in 2 times 6 times pi or 2 times pi times 6, it'll spit out 12 pi for you. It'll keep that pi value in there. Just like it did the other day, last chapter or a while when we had those root 3s and root 2s. Whenever you had to multiply by a square root or you divided by a square root, the calculator kept it in what we call simplified radical form. It does the same basic thing with pi, with its calculations with that. It's very rare that it will spit out a decimal. There will come a time, and I have an example of that here later on, of when that happens. But just so you know, if you don't have the multi-view, if you had to find circumference, all you have to do is take 2 times 6, press enter, and then slap a pi next to it. Really all it is, all right? We've got tons and tons of examples here to make this work. So, arc length. If our circumference is going to be equal to 2 pi r, when you're dealing with the arc length is going to be a portion of the circle, so it's the portion of the circumference. Well, what we need to be able to do is figure out how much of the circumference is being used. Well, how many degrees are in a circle? 360. This arc length is taking up some value of that circle. So really, all we do to figure out arc length is the following. The arc length equals your angle over 360 times your circumference. It's the portion of the circle. Well, if you've used 60 degrees of the circle, you're talking about 60 degrees of the arc length. 60 degrees is 1/6 of the arc length, or 1/6 the circumference, excuse me. If I do half the circle, it's going to equal half of the circumference. That's where it works out to be. It's just a fractional amount. There are 3 different ways you can write this out by looking at the circumference parts, because 2 pi r is the same thing as saying what? What's that? Pi times the diameter, very good. So the other way you could write this, and the reason why I'm saying this is at the end of the hour, or towards the end here, I've got a couple examples where you're going to find just a diameter, or you're going to find maybe a circumference. Oops. So there are 3 ways of writing these things out. Why does the loft house always steal my markers?
Here's a marker.
That's too skinny.
You're too skinny.
Okay.
He said, okay.
You have 2 over on the other board.
Is the vertebrae somewhere here? Have any of you guys tried to go through some values of pi yet?
No.
I think there was, I want to say it was first hour, someone's got 16 digits and he was very, very proud. So here's how this stuff's going to work. Arc length. I have a central angle of 110 and a radius of 3. I'm going to ask a couple of questions. The first question I'm going to ask you is, what's the measure of the arc? 110, very good. The measure of the arc is always going to equal the measure of the central angle. So my central angle is 110. That means my arc will measure 110. And now it's just a matter of filling in the blanks for the rest of it. To get to the arc length, when I get to do the arc length, what I need to worry about then is put the central angle over 360. And multiply it by the circumference. 2 times 3 times pi. Now, all you need to have then is your calculator and know how to press the button that creates a fraction. It's very, very hard to do. Yes, very difficult. This is one of the most difficult things you will do all day. Now, my calculator will not leave it in terms of pi. So when I show you how to press the buttons, I'm going to do everything except press pi. I create the fraction bar. I type 110 over 360. I move it to the right. I press the button that says times. 2 times 3. And I hit enter. I get 11/6. Excuse me, 11/6? 11 over 6. What do I need to do to that to keep it in terms of pi?
Put a pi next to it.
Put a pi next to it. That's
You
it.
want 11 pies, not 6 pies, obviously.
Correct. 11 pies are more delicious than 6 pies.
Depends on what kind of pie it is.
That's true too. People always ask about the whole where does the pi, why is the pi in the numerator as opposed to outside of it? 11 pi over 6 is the same thing as saying 11 over 6 times pi. This is the more math etiquette way of writing it. As you are writing it out in terms of fractions like this, next year when we get into the trig stuff, we start talking, I've mentioned this before, the whole idea of what we call the unit circle. the unit circle is a measurement of between 0 and 360 degrees as you go around. But when we put it in terms of pi, we change into things that are called radians. Radian measure is actually on your calculators, the button that says, you know how you change your mode to rad? It's not just because it's awesome. Did I show you the movie Rad yet?
No.
I'll show you that one of these days. What happens is that in the unit circle, we talk about things in terms of pi. For example, if this is 0, that's 180, that's 360. The time it takes you to go one full revolution, we say is equal to 2 pi, which means half of it would be just pi, and so on and so on. 11 pi over 6 comes around, it's almost 2, it's here. And that actually is a radian measure that we use in algebra 2. Just so you know why we write things out that way. So really the only reason why I'm telling you this is because it'll prepare you for next year. When you see this, you won't go, we probably will still, but at least somewhere in the back of your dark skull, you might remember something, which would be good. Because your algebra 2 teachers might be nice to you then. Doubt it.
What if you're algebra 2?
I feel sorry for you. Not so bad?
Are you gonna cry if you have this for algebra 2?
Yes. No, maybe so. Sure, why not? Same deal. What's the measure of the arc? And then what is the arc length? Excuse me. So in this oh so awesome example, I have a central angle of $1.50, which means what's my measure of my arc? 150. Arc measures and central angles are always equal to each other. Bless you. When I go to work with the arc length, what do I need to know? What am I missing? Radius. All right, give me a number. 4. There's your radius. So if 4 is my radius, let me move this over just a little bit. If 4 is my radius, I have my arc length is angle over 360, 2 pi r. I just fill in the blanks. 150 over 360 times 2 times 6 times pi. I'm sorry, 4. Simplify your fractions. Those go. This becomes 18. This becomes a 9, 2, excuse me, a 3 and a 5. I get 10 pi over 3. Or you go through and you press a bunch of buttons on your calculator and you simplify it out that way as well. All right. What if you had to find the arc length? What if I had to find the arc length going the other way? ACB. What would that central angle be? What could you do to figure that out? If your one angle is 150, how many are left to get you all the way around the circle? 10. Thanks for keeping up there, Joel. So then you do 210. And you have a 14 pi over 3, I believe. What? Why did I do what?
Makes me so sad.
What? All I'm doing here is just simplifying. You guys always tend to seem to freak out when you see stuff like that. What do those two numbers have in common in the fraction? Zeros. You knock out the zeros. 4 goes into 36 how many times? 9. That goes away, this one comes in 9. 9 and 21 are both divisible by 3. 7 times 2 is 14. Slap a pi next to it, put it over 3. Fractions are your friends. Fractions are your friends. All right, take a minute. Find the arc lengths of the red. Sometime earlier today, people were having problems figuring out which ones were the reds. Find the arc lengths of these red ones. Please and thank you. What's up? This isn't frightening you too much, even though we have a couple weird ones coming up here. So you have 60 over 360, 2, 8, and a pi, 1/6, 3 and a 4. You get 8 pi over 3, I believe. Okay. It's really nice when you have fractions that can work out real clean, especially with 60s and stuff like that. 1/6. Hey, look at that, another 60. Wow. So you have 60, 360, 2, 11, and a pi, 1/6, comes a 3, you get 11 pi over 3. Now take a look at the difference between the second and the third circles. Don't they have the exact same radius? If circles have the same radius, wouldn't they have the same circumference? Yeah. So what's the difference between 60 and 120 degrees? It's just double, isn't it? So if I double 11 pi over 3, what do you get? 22 pi over 3. It works. That's the reason why I wrote this. I wanted to show you guys that. Sometimes when you get the same, you have the same radius and the angles are just doubled. That just means the distance of the arc has doubled. So if you go out a long way, you'll still get the same answer, but this one will also be 22 pi over 3. Now, not always are you working with just straight, hey, find the arc length, bozo. It might say, hey, knucklehead, find the radius. And you got to work backwards. For example, when was it? If I'm looking at something like this, where it's going to ask me to, it'll give you, well, actually, let me rephrase this. If you look at the formulas for arc length, you have basically 3 unknowns. The arc length, the angle, and the radius. The arc length, the angle, the diameter. The arc length, the angle, the circumference. So as long as you know 2 out of those 3, you can always find the third. It doesn't matter which one it is. So in this case here, it's asking you to find the radius. So first thing you would do is figure out, of these 3 formulas of the generic form, which one of them has the letter R in them. The first one. Very good. So I'd write it down. The arc length is your angle over 360 times 2 pi r. Well, what's the arc length according to the diagram? Huh?
18.
It's 18 pi because it says so. What's the central angle? It's 90 because there's a square there.
Bingo.
So basically what happens is that you need to simplify that first. After you simplify that first chunk, no matter which one of these three you might be using, from there it's just a one-step equation. You're going to multiply by a reciprocal. No matter what, you're going to do the exact same thing. So if you put 90 over 360 times 2 pi in your calculator, it'll spit out for you, dun, 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 it'll spit out pi over 2. One, 90 times 2 is 180, 180 over 360 is 1/2. 1/2 times pi is pi over 2.
My brain needs enough of this.
It needs a what? No, I'm okay. So now, how do you undo multiplying by a fraction? Well, we don't divide by fractions because that sucks. So what we do is we multiply by its reciprocal. All right. We always want to just go ahead and multiply by reciprocals. By multiplying by the reciprocal, you undo this side. So you have just the radius. So you have 2 over pi times 18 pi. What's that 18 pi over that you don't see? 1. When you multiply fractions, you're just multiplying straight across. What's 2 times 18? How much? 36. Pi divided by pi is 1. So your answer is 36. If you are unsure on how to do that, you could still, once again, press buttons in said calculator. Make the fraction 2 over your pi. And multiply that by 18 pi. And you'll get the same thing. There is no excuse not to get these things correct because you have a calculator. Oh, that's right, you need to make sure you bring that calculator. I know, I ask a lot. I know. Me and my silly high expectations, like saying wait, things like that.
I'm gonna try to choose, but it sounds like
That'd be awful. So this one, it could ask you for just finding the circumference. Sometimes it might just ask you for that as opposed to a radius or a diameter. It could ask you for any one of them. It's just a matter of reading it and then filling in the right formula. So if you have a central angle of 60, an arc length of 15, and you need to find your circumference, well, that means I'm going to write down which of the 3 formulas. The top, the middle, or the bottom. The bottom, because C stands for circumference. So your arc length is angle over 360 times your circumference. Fill in the blanks. What's the reciprocal of 60 over 360? Flip it, which is 6. Your circumference then is 90. What's wrong, Phil? What's wrong? 60 over 360 is 1/6. The reciprocal of 1/6 is 6. Hey! You're back! We missed you. You all right?
Oh, lights out.
I have the 11.4 tab already open. I posted it on the calendar. Right. The answer's 90. 90 circumference. I forgot what page it was.
Double month. 7 years. It's a lot faster than other How do you do it?
Do those, please, and thank you.
There's no foot there.
What's up?
May I go to Chennai?